Okay, I think it's going. Oh, there it is. There's the sound I was waiting for. Okay, so let's get started with our first lesson. If you have questions, if you can just type a Q in the chat or raise hand or something, because then I'll stop speaking and let you ask your question. So Unit 1 is all about rational expressions or algebraic expressions. And the first thing we need to go through are a couple definitions. So a rational expression is an expression that is the ratio of two polynomials. In other words, it's a polynomial divided by another polynomial. So it can be expressed as y equals r over s, where r and s are polynomials. And now the really important piece is that s cannot be 0. So remember, we can't divide by 0. So that bottom part under the fraction can't be 0 ever. So we really need to be mindful of that, and I'll show you how to deal with that. So here's a quick example. So we have x squared minus 2x plus 3 all over 4x minus 1. Now this part here cannot equal 0. We can't have the denominator being 0. So how we find the numbers that x cannot be is we find out what would make the denominator equal to 0. So I'm going to set it equal to 0, and I'm going to solve for x. So we move that 1 over, and then I divide out the 4. So the bottom would become 0 when x is a quarter. So that means that that is the only number that x cannot equal. And that x not being able to equal a quarter is what is called a restriction. And that is whatever values of my variable would make the bottom 0. So we're going to go through and we're going to practice finding our restrictions, but they're very, very important because if I were to graph this relation or if I was using it to model a real life situation, it's very important for me to know what values x cannot be, right? Because we cannot divide by 0. So there are a few steps to this for when we are simplifying these rational expressions. And the first thing that we will do is we have to factor our numerator and our denominator. So we will be practicing some more factoring. And if you are still struggling with factoring and you need extra help, make sure you let me know, because factoring doesn't go away and we're just going to kind of run with some of the factoring throughout this lesson. So if you are feeling a little confused, please make sure to reach out. Once we have factored, we are going to reduce. And we're going to reduce by canceling common factors. So I'll show you what I mean by that in the first few examples. And finally, we're going to find our restrictions. And we do that by looking at our denominators and finding all of the values that would make the denominator 0. And of course, we'll go through how to do all of that and make it nice and clear. Okay, so now that we've gone through the background info that we kind of need to know, we're going to dive in and start doing some examples together. And we're going to do a bunch of them together, and then I'll leave a couple for you to try on your own, depending on our time, because there are lots of practice ones in the homework. So let's start with these examples. We need to simplify the rational expressions, and we need to make sure we state our restrictions. So from now on, please always state restrictions, even if it doesn't ask you. So even if the question just says simplify, if you don't include your restrictions, you will lose a mark. So please be mindful of that. Once we start doing this, the restrictions become very, very important. So we'll start with example A, and we have r squared minus 5r all over r. So the first thing that we're going to do is we're going to factor the numerator. And when we factor, the first thing we always do is see how much we can common factor. So those both have an r in it. So I can get rid of the r, and then I'm left with r minus 5 all over r, like this. Next, I want to reduce it, and I want to do that by canceling things. Now, sometimes people find it hard to know when can I cancel things? Like, when am I allowed to do that? Once you have fully factored and everything is in brackets, so if there are plus or minus signs, they're within a bracket or it's the only thing on the bottom, that's when we can cancel things. So in this case, I have r and r minus 5 all over r. So because I have a lonely r here and a lonely r here, those two things cancel, and I'm left with r minus 5 as my final answer. Now, the last thing I need to do is I need to find my restrictions. So when you find your restrictions, you go through all of your steps and make sure that you find any restriction that existed at any point in your simplification. So if I look, I have an r on the bottom here. So r cannot equal 0, because if this equaled 0, the bottom would be 0, and we can't have that. That is a problem. So r cannot equal 0. Any questions so far? We're going to go through these nice and slow, and then we'll kind of start to add on some more difficulty. We're okay? Awesome. Oh, and everybody's here. Amazing. Okay, let's try another one. If you have questions, please feel free to stop me. I'm more than happy to help. So this next one here, we have w squared minus 6w plus 8 all over w minus 2. Now, our first step is to factor the numerator and the denominator. So I'm going to factor this one, and I'm just going to do all the work off to the side. As we go forward, we'll speed up the factoring a little bit, but just so everybody's on the same page. So I need to factor w squared minus 6w plus 8. So my a value is 1, so it's a simple trinomial. So I'll make my little chart. Two numbers that multiply to 8 and add to negative 6. And then I would find that they are negative 4 and negative 2. So I can put that right in here. It's a w minus 4, and w minus 2. You don't have to write all this stuff out. I just want everyone to know where our numbers are coming from. So this top bit changes to w minus 4, w minus 2, all over w minus 2, like this. Now that everything has been factored fully, I can begin canceling stuff. So I have a w minus 2 in the denominator and 1 in the numerator. So my final answer is w minus 4. The final step is our restrictions. And although my w minus 2 cancels out, at one time it was in the denominator. So we do need to make a restriction for that step. So from here, for that to be 0, would have w minus 2 equals 0. So w equals 2. So that means that w is not allowed to equal 2, or else it will zero out the bottom, which is what we really don't want. So that would be our final answer. Please make sure that we are including all of these restrictions. It is very, very, very important to know how to do. Do you have to do that for every step? The things that you need to include here are, you don't need to include this. Oops. I'm okay if you didn't include all your factoring work off to the side, that's fine. But you need to include your restrictions. You only include it at the end, but you need to make sure that you have restrictions from every step. So if I had canceled something out earlier, we need to make sure we have it. As we go through, I'll show you more examples that have more situations with the restrictions, which will hopefully clear some things up. Okay, so let's try example C. Justin's asking if when I post the videos. So if you go under class work, when you click the lesson, attached will be the video. But we'll see how this even works. The recording might be so terrible because the Wi-Fi is so bad that we might not be able to use it, but we'll definitely give it a try. All right, let's try C. So C is actually very familiar to a lot of those exponent law questions we were doing from before. So we have 30 x to the power of 4, y to the power of 3, and 6 x to the power of 7, and y. So it's up to you. You can factor some things out, or we can do it like we did before. My recommendation would be to do it just like we were doing before. So we start with our coefficients. 30 divided by 6 leaves us with 5. Now for my x's, I have 7 on the bottom and 4 on the top. So when those cancel, oops, sorry, that should have been purple. So when those cancel, I'm left with 3 x's on the bottom. And then my y's, I have 3 y's on the top and 1 on the bottom. So when those cancel, I'm left with 2 y's in the numerator. And these are just like what we were doing before, so hopefully that isn't too new. But the same principle is really happening when we're dealing with these polynomials. Any questions so far, or are we okay? This lesson isn't super long, so once we kind of get going through things, we're gonna fly by. Okay, let's try another one. We'll go to D here. And D says 12 minus 4t all over 4t. So the first thing we always do is we factor the numerator and the denominator as much as we can. Oh, thank you, Braden. I forgot about my restrictions for C. Sorry about that. My brain isn't working. So I do need to look for restrictions for C. Right after I said you always need restrictions, I'm not even doing it. So I look at the bottom and I have an x all by itself. So x cannot equal 0. And then I have a y all by itself. So y cannot equal 0 either. There we go. Sorry about that, everyone. Did not mean to forget that. Okay. Now we'll go over to example D. So we have 12 minus 4t all over 4t. So first thing we always do is factor. So we'll look at our numerator and we will start by common factoring out as much as possible. So I can take a 4 out and I'll be left with 3 minus t all over 4t. And now I see, as soon as I'm done this question, I'll answer. I'll finish this one and then I'll answer those questions. Okay, guys? So I have 4, 3 minus t, and 4t. And now I'm just going to cancel what I can. So I can cancel both these 4's, and I'm left with 3 minus t all over 4t. Now I need to do the restrictions. So I look at my denominator, and if that is going to be 0, t cannot be 0. And that would be my final answer. Oh, it is. Thanks, Georgia. Oops. There we go. Okay, so there's a few questions in the chat that I want to address. The first one is that Nolan asked, what's the point in doing restrictions? So the reason why we do restrictions is what this means is when t equals 0 for this question, this whole thing doesn't exist. So with this thing here, if I were to graph it, let's say, I would have a space on the graph that doesn't exist where t equals 0. That's what would happen. Or if we were using this in a real life application, there would be a value that just doesn't work for an area problem or a volume problem. And it actually makes a huge difference because if I divide by 0, it's undefined. So it's really important that we write all of those down. The next question was the restrictions for C. Sorry, I did forget about those, so I quickly added them, so you may have missed it. But they're just x can't equal 0 and y can't equal 0. I just forgot to write them, so that's where they are. Oh, my computer's being super slow, so yes, and then I forgot that. That was fine. Okay, this is a really good question. Why can't I cancel the t? So that's a really good question, and I want to address it. So there's a few people putting in some guesses there, right? Because it's a negative t. Nope, not quite that. And the t at the top and the t below. These are all really good points and super common errors. So why we can't cancel these t's here is there isn't a factor of t with this 3. This 3 here doesn't have a t attached to it. I can only cancel it if everything has a t. So if we had 3t minus t or something like that over t, I could factor out that t and then they could cancel. If I have a situation where there are still addition or subtraction signs not in a bracket, I can't cancel stuff. This is such a good question because it's a very, very common error that people don't know when to cancel things. And we're going to go through a bunch, and I'll show you the difference of when you can cancel something and when you can't cancel something. So if it is not a perfect match or it's not in everything, we can't cancel it. So again, because there's no t on this 3 here, we can't factor out a t to cancel it. So hopefully that clears a few things up. It can be a little confusing. We'll go through a few others and hopefully it clears some of these questions up. So Jasmine asks, how do I know when to do my exponent laws in C versus factoring like this? The difference is this negative right here. So if there are multiple terms that are added or subtracted together, that means we have to factor. Okay, so I think I got everybody's questions. Feel free to type it again if I missed it, but I'm going to do it again and hopefully I can show you why we can't cancel stuff. So let's look at E. This is another good example of why I can't just cancel stuff. So let's start there. So I cannot just cancel these x squareds. I cannot do that. And the reason I cannot do that is because of these addition and subtraction signs. The reason I can't cancel them is because not all of these have an x squared. So if I have plus or minus signs here and they're not in a bracket, I can't start canceling stuff unless I have the exact same little term or little factor. And I'll show you what I mean by that in a moment. But when you're trying to cancel that t in the past example, it's the same thing as if you did this, which you definitely cannot do. So what we're going to do here is we are going to first start by factoring. So once I have factors or multiples of something, that's when I can start canceling. So I'm going to go through and I'm going to actually do the factoring so we can all see the factoring. So we'll factor this one over here, x squared plus 2x minus 8. So our little chart, two numbers that multiply to negative 8 and add to 2 are going to be 4 and negative 2. So this factors to x plus 4, x minus 2. So if you are having a tough time with the factoring, I highly recommend that you keep practicing that and email me if you have questions. And then for the denominator, we have x squared minus 3x plus 2. So to factor that one, two numbers that multiply to 2 and add to negative 3 are going to be negative 1 and negative 2, like this. So that just factors to x minus 1, x minus 2. So now let's fill all of that into my example. So we have x plus 4, x minus 2, all over x minus 1, x minus 2. Now that everything is being multiplied or in brackets, now we can start canceling stuff. So see how here all of my plus or minus signs are within a bracket somehow versus here where they're not? That's what we're looking for to know we can cancel stuff. So now I look to see if there are any factors that are in both my numerator and my denominator. So I have an x minus 2 here and an x minus 2 here. So those are the ones that cancel. So I'm left with x plus 4 all over x minus 1. Next, I need to do my restrictions. So what would make the denominator 0? So if this is 0, that would make my denominator 0. If this is 0, it would make my denominator 0. So x cannot equal 1 from the first bracket or 2 from the second bracket. Do the x's cancel out here? So the x's, just like before, the x's do not cancel out because they are not being multiplied. See here how these are being multiplied with these brackets? So we can do a whole bracket, but the x's cannot cancel out. Canceling out the x's here in this step would be the same as canceling out these x's, which we cannot do. So if things are being separated by plus or minus signs and they're not in brackets, we can't just cancel stuff out. So as we go through this and we do more, it starts to become more apparent when things can cancel and when things can't cancel. All right, let's move on to our next example. Don't mind the bells going off like crazy. Okay, so let's try example F. Try another one. So for this one, I have y squared plus 9y minus 10. So again, we can't just cancel things like this out. And the reason why we can't is because things are separated by plus and minus signs. We have to have things factored in brackets, multiplied. That's the only way we can cancel stuff out. So let's start by factoring. So I'm going to factor my numerator. So I have y squared plus 9y minus 10. And my a value is 1. So it's a nice and easy one to factor. So two numbers that multiply to negative 10 and add to 9. So we'll have 10 and negative 1. So it factors to y plus 10, y minus 1, like this. And then we will also factor our denominator, which is y squared minus 1. So this is a difference of squares. So because I have a squared first minus another square, that is the difference of squares. So I do the square root of the first one plus the square root of the second one, square root of the first one minus the square root of the second one. So now let's put all of that back into our equation. So we'll have y plus 10, y minus 1, all over y plus 1, y minus 1. So now that everything is in brackets and multiplying, so this is being multiplied by that whole thing. Now that we have everything set up like that, we can start canceling things. So because I have a y minus 1 in the numerator and in the denominator, that part can get canceled out. So I have a y plus 10 all over y plus 1. And I can no longer cancel things out because these whole brackets don't match. It has to be the whole thing that matches. Finally, I have to deal with my restrictions. So for this one to be 0, y can't equal negative 1. For this one, y can't equal 1. So that is our final answer. Any questions about that one? I'm hopeful that as we keep going, it starts to make more and more sense each time we do it. Okay? All right. I'm just going to give people a moment to make sure they've written everything down, and then we'll move on to the next few. That y can't be any negative number because it's squared. So y can still be a negative number and it will work itself out. So because this here, when I factor it, is the same as this. These two things mean the same thing. So as long as I factor correctly, these two base expressions mean the exact same thing. So the values we get for y in this one would also zero out for this one. It's just a lot easier to find it when it's factored, but it's a good idea kind of to think of that. That is actually why that idea of it being squared is why we get the plus or minus 1. That's where it comes from. But just once it's factored, then start doing your restrictions. It's a lot easier to find that way. Okay, so I just don't want to rush people. It's so hard when everything's online to know if we're okay to move on. So I'll move on to the next one. I will post all these answers. So if there is anything you realized you missed, don't stress because I will post it all. So this next one, 4x squared minus 16y all over x squared plus xy minus 6y squared. So these ones are getting a little more challenging just with the factoring. The actual underlying concepts of when we cancel stuff, all of that are actually the exact same. So the first thing I'm going to do is I'm going to common factor out as much as I can. So in my numerator, I can factor out a 4. So I'll have x squared minus 4y squared, like that. And I can't common factor out anything from the bottom. If you are skipping some steps here, that's totally okay. So now I'm going to continue factoring these two things. So this thing here is a difference of squares. So I have the square root of the first one plus the square root of the second one. and then the square root of the first one minus the square root of the second one. So if you are finding the factoring a little intense, please make sure you practice it, ask me for help, all that stuff. And then it's all divided by, we're going to factor this thing here. So we have, x squared plus xy minus 6y. So when you have something like this, we're going to factor it exactly as we factor everything else, and then we'll deal with the y's later. So we'll get our chart, two numbers that multiply to the last number and add to the middle number. So there's a coefficient of 1 here. So that would be 3 and negative 2. So now I fill in my brackets the same way. The only difference is I have a y at the ends. Like that. So now that I have that factored, I can put that over here, x plus 3y, x minus 2y, like this. And now that everything is in brackets, I see what I can cancel. So I have a x minus 2y in the numerator and in the denominator, so I can cancel those. And I'm left with 4x plus 2y all over x plus 3y, like that. And finally, have to make sure I do those restrictions. If you don't have your restrictions, you will lose marks. So please, please write them. So for my restrictions, the one that comes from here, so sometimes they're not easy to find. So I have to see what happens when I set it equal to 0. So what I'm going to do is just rearrange to isolate x. So that's my first restriction. So x cannot equal negative 3y. And we'll do another one for here. Even though it canceled, we need to make sure that we account for that restriction. So we have x minus 2y equals 0. So x can also not equal 2y. Okay, so I see some questions in the chat that I want to quickly address. So the first question was, can I use the distributive property with the number? I certainly could. So you absolutely, for your final answer, could distribute this foreign. It is not necessary to do, and I would be mindful of it just in case, let's say this was like a part A, B, C, and you needed to use your answer again and things continue to cancel out. It could save you some time if it was already factored. However, you absolutely can, and that's fine. It's absolutely not wrong. And that was Braden's question too. Perfect. And then Jasmine asked, so the restrictions are only for the numbers in the denominator? Yes, exactly. And the reason they are is because I just can't divide by 0. If I have 0 like over 5 in a fraction, that's fine. I just can't have 5 over 0. That's the difference. Natalie asked, oh, this is a good question. Do we still write the restriction for the term we cancel? Yes. And that is really, really important. And a lot of people tend to forget about it. So even though we canceled out this one, we still have to write its restriction. So even if like at some point there was an X or Y on the bottom, and even though it was canceled, we still need its restriction there no matter what. And Justin was just confirming about the denominators. We just can't have the denominators equal 0. Okay, hopefully that clears some things up. We're going to see how many of these we can get through. And then tomorrow is, we're continuing on, but the material is very, very similar. So if you don't feel like you're grasping it right at this moment, don't panic. we're going to continue on with it more and more, and it does kind of click. All right, let's do the next example. I realized I kind of made that a little too close, so I need to move that. But we'll try our next example. This one is a little bit more intense, but there's a little bit more happening, so some more room for me to address common errors. So we'll do H together too, and then I really want to get to I. I think we'll be okay. If we don't get to I, we will figure it out. Actually, just to make sure we get to I, let's do I first. Sorry if I'm like confusing people, but just in case 155 comes and people have questions, I'd prefer to save H for you to do on your own. Christine asked, if we don't finish them, can we go over them tomorrow? Yes, tomorrow's lesson is a little shorter. I do want to do I today. That way you guys can try the other two on your own, or even just H, because you have the skills to do that. I's a little weird. So let's quickly simplify I. Then you guys can do the homework tonight, and we can take up any questions tomorrow at the beginning of class. So I is x squared plus 7x minus 8 all over 2 minus 2x. So the first thing I'm going to do is I'm going to factor this thing. So we'll factor this one, x squared plus 7x minus 8. So two numbers that multiply to negative 8 and add to 7 would be 8 to negative 1. So we'll have x plus 8, x minus 1. So that's what goes in our numerator. There we go. And then in the denominator, we are just going to common factor out as much as we can. So we have 2, then 1 minus x. Now, if you look here, we have almost something that can cancel, right? We have x minus 1 and 1 minus x. They're close, but not exact. And we can only cancel them when they are exact. So we're going to quickly go through a strategy to make them exact. So what I'm going to do is I'm going to factor out a negative 1 out of this bracket here. So I'm going to factor out negative 1. So now I'll have negative 1 plus x, like this. And I'm doing a few extra steps here, which you don't necessarily need to write them all. Just want to make sure everyone sees what's going on. So now that little bracket, I can rewrite like this. So sometimes that's a strategy that you can use. Sometimes it works, sometimes it doesn't, but it is a really beneficial strategy because now I do have matching brackets that I can cancel. So I can cancel this and I can cancel this, and I'm left with x plus 8 all over negative 2. And finally, my restrictions, always need those. I look for any point where there's an x on the bottom, and I have that x cannot equal positive 1. And that is my final answer. Any questions about that one? It's a bit of a tricky one there. We're okay? All right, so we've basically kind of reached our time. So I'm just going to quickly end the recording and explain what your expectations are for tomorrow and what we'll go over tomorrow. If it lets me end the recording, it's being so slow.